See this. We are supposed to show that this determinant is product of these two determinants, which means square. The product of these two determinants. These are two determinants because there is square. And then finally we are supposed to show that the value of this determinant is this one. Okay, so what I'll try to do is I'll try to write every term. See, whenever we have to write it as if it is a product of two determinants, you have to see that every term is actually sum of three terms, and every term in the is product of two terms. Okay, every element should be written as if it is sum of three terms, and every term should be written as if it is product of two terms. So it is better that you work backwards to get this. You can take this and multiply with it, and then you try to get there. It is better if you work backwards, but anyway I did it in this way, right? With practice you will be able to see this, but it is not very intuitive, which means you will not be able to do it directly, but with practice you will be able to do it. Okay, now just see this. Since there are only two terms here, I am expanding this as if it is three terms. There is a 2bc minus a square, therefore I am writing minus a square plus cb plus bc, right? And then here there is c square, and c square only one term is there. Just to write it as if it is the sum of three terms, I am writing it as minus ab plus ab, right? There is only one term here, which is b square, and now in order to write it as if it is three terms, I am going to write it as if it is minus ac and plus ac, therefore I can write it as three terms. Okay, so if you observe it, every element is written as if it is sum of three terms. Okay, and now if you observe here, there is a here, b here, c here, a b c, a b c, right? And now if you take out a b c, what will be remaining? Minus a c b, minus a here, minus a c b. So likewise we can separate it out. So if you see this entire determinant can be written as if it is product of these two determinants. How? You can apply the row by row matrix and see that we get this. See, row by row multiplication. Take this one and you multiply with this, you are going to get this term. Take this first row, multiply with this second row, you are going to get this one. Take this row, first row, multiply with the third row, you are going to get this one. So by doing row by row multiplication, you can see that we know this is nothing but the product of these two determinants. Okay, so now if you observe it, we can take out minus 1 as common, and then I want to exchange these two. Already minus 1 is taken out, and when I exchange these two, I get one more minus 1. So when I multiply these two, it is going to be plus 1. So I can remove this sign and I can exchange these two. I think not these two, I want to exchange these two, second column and third column. I can exchange these two, and I can show that these two determinants are actually same. Then I can write it as if it is square of the original determinant. Got it? And now we have shown this part, that the given determinant is nothing but square of this determinant, and I want to show this one. So just to prove this, I'll take this single one, this small determinant, and I'll evaluate it. When I evaluate it, just the normal expansion, a into bc minus a square minus b, a into bc minus a square minus b into b square minus ac plus c into ba minus c square. So if I write like this, this is what I get is the value of this determinant. Okay, and anyway we are going to square it, therefore when I square it, you can rewrite it like this. Okay, so this is what the answer is. Got it? So we have shown this part also. So what I mean to say is, most of the determinants can be expressed as if they are sum of two determinants or product of two determinants. Most of them, not everyone. Now once we are able to do it like this, it will be easier for us to find out the determinants, the value of the determinant. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.